Hi, I'm Brownfield Anchor reporter Brent Barnet, and this is Unlocking Potential on Brownfield, a content partnership with Advanced Agrilytics. Joining us today is Colton Zeck, precision agronomist with Advanced Agrilytics. Colton, how are you doing here today?
Hey, I'm doing well, Brent. How are you doing?
We're doing fine. Can you talk first, Colton, a little bit more about your role with Advanced Agrilytics and the area that you cover?
Yeah, for sure. Like I said, my name is Colton Zeck. I'm from southeastern Indiana. My role here at Advanced Agrilytics is a precision agronomist, and down here in our area, we're privileged to work with some of the best farmers in the Corn Belt. So we have a lot of fun down here.
Well, on this episode, we want to discuss smarter starter fertilizer. The first question any farmer asks about is typically weather and precipitation. When we're talking about starter fertilizer, why does this matter?
Well, I think there's a lot of things that you can consider, taking last year as an example here. Nitrogen and sulfur, naturally from a mechanism standpoint, working through mass flow, we need water to make that happen, right? And so, last year we were definitely lower on total overall precipitation, but for those of us in the area that were able to, bolster that early season growth and really try to target maximum V6 plant mass, we were able to overcome a lot of those issues that we'd have with the lack of rainfall.
Growers have been turning their attention to the application of starter fertilizer for 2024 planting. Now, often the reason given for application of this fertilizer, Colton, is to get the crop off to a good start. So, how can we get more specific in our goal for what that starter pass is intended to do?
I think personally, I think it's one of those areas that, as an industry, that we've fallen a little bit short on our understanding of maybe what that starter pass is intended to do. If you think about it, everybody with their same old 10-gallon rate of 28 and 1034.0, going flat across the field, is that really precision agriculture? Is there a way that we can get more precise with what that starter pass is intended to do? And typically, just like you said, as we have conversations with growers down here in this area, and we ask them, what is the goal of that starter pass for you and your operation? And a lot of them will look at you and think, I just need to get it off to a good start. But our question back to them, well, what is a good start? And I think a lot of that, and the way that Advanced Agrilytics has gone about thinking fundamentally using spatial data is, even some data going back to 2015 and 2016 that we found the importance of V6 plant mass according to yield, or tying to yield. And one of those things that we found was that as we approached a 19, 20, 21 gram above ground dry mass at V6, our ability, or our potential rather, for 250, 260 bushel corn dramatically increased. And the other good part about that was our downside risk of having that big V6 plant mass was almost zero. Whereas on the other side of the coin, if we had plants that were 13, 14 grams, yeah, if we had everything work in our favor weather-wise throughout the year, it's not to say that plant couldn't obtain that 250 bushel mark, but man, it had to have everything going its right way to do it. And last year, we were just a couple days away from catastrophe, almost a 2012 scenario again. And so with our understanding on that planter pass, specifically talking about starter fertilizer, our goal is to look at, the environments that we're in and build that 20 to 21 gram plant mass at V6 in all environments. And we found that when we do that in conjunction with our other methodology that we implemented, Advanced Agrilytics, our yield stability and our yield potential dramatically increased.
Even with adequate rainfall, we all know that the field spots that run out of water each year. How can growers prepare for that stress in terms of their starter fertilizer application?
I think it comes down to acre tendencies. Year after year, we know there are areas in our operation and in our fields that will inevitably dry out, right? Year after year, roughly 30% of our acres are going to be quote unquote water limited, or experience some sort of drought-like conditions. Last year, it was greatly magnified. We were really short on total rainfall, and so those areas got exploited even greater. But for us, as we're looking at that starter application and talking specifically about V6 plant mass, what does the largest V6 plant bring us? What are the benefits of having that large V6 plant? And I think, the number one thing is shading the row, and expediting that race to canopy that we always talk about, and hopefully getting there within 30 to 45 days, especially on that water limited area and where we're a little bit higher in landscape, further away from the water table, areas that are going to mineralize less organic matter and sulfur naturally. But if we have that big V6 plant mass, as we shade that row, we're going to be preserving more soil moisture, right? So we won't be losing it to evapotranspiration. Another benefit of that V6 plant and having the biggest one possible is it's going to capture more sunlight. And so if we're capturing more sunlight, there's a lot of good things that are going to happen to that, especially as we talk about, building sucrose as we get to that R1 stage and we enter into grain fill. And among other things, a larger V6 plant takes up a lot more nutrients. And there's, one very, important thing that I think we all know that happens at V6 is that corn plant's determining how many rows around it's going to set on that ear. So right then and there, it's kind of a vital checkpoint for us is to build that biggest plant we can, because when we do, we have a lot of good things moving forward for us as we enter through rapid growth and then into pollination and then inevitably into grain fill.
Colton, can you talk about some trials that Advanced Agrilytics conducted last year that looked at evaluating the increase of nitrogen rates in planting?
Yeah, we had numerous trials across the Corn Belt, but I'll talk specifically to our trial we had down here in southeastern Indiana. And part of this new technology where we're talking about varying the rate of our starter on the planter pass, there's a couple things that you have to keep in mind that would make it different than your standard, I'm going to put 10 gallons across the field. One thing is we have to figure out what our organic nitrogen contribution is spatially throughout the landscape, specifically on that area that we know has a tendency to dry out quicker. So again, higher in landscape position, typically lower in organic matter, it's going to contribute less. So then we have to look at it and say, well, what do I need to put on with the planter in that area to make up the difference, to make sure that while that plant is getting to V6, it doesn't hint a lack of nitrogen until it gets to its primary nitrogen source through that side dress or pre-plant that will carry it throughout the rest of the growing season. And so in our trial down here in our area, this was on a grower who was running a blend of an 80-20 blend of UAN 28 and ATS. And this was a pretty stressful, one of the more stressy fields in the geography. CEC is lower than 10, organic matter typically less than 2 throughout the area. Trying to calculate that organic nitrogen contribution showed us that it was going to require some gallons to meet that fulfillment. And so what we did is we ran that variable rate prescription to full fulfillment, which is essentially saying that, every grid that we have in the field is being fulfilled with the total amount of nitrogen and sulfur that it needs to achieve that 20 to 21 gram V6 plant mass. And from there, we embedded some 7 gallon and 12 gallon flat rate check strips going across all those different environments. And then we were going to analyze it. And so what we did at V6 is we went out, we pulled plants in 2 different environments, pulled one from that, what we would consider the low SWI area, or that acre that is higher in landscape. We know that water sheds away from it when we get a significant rainfall. Took plants there, took them back and weighed them. We also took plants from that higher SWI area where water is actually going to be moving to, and we have a little bit better mineralization capabilities of organic matter, and we compared them, right? And so we dried them out and we weighed them, and what we found was that in that VR strip, we were able to achieve the exact same plant mass at 21 grams in both environments. And that was something that really opened our eyes, was, hey, we figured out something. We can build that robust plant here on this knob just like we do down in the good ground. And so when we were looking at the trial and we got to V6, we're like, hey, the other thing to keep in mind is, what is this going to mean in terms of yield potential moving forward? Because let's be honest, starter fertilizer is a polarizing topic depending on what farmer you talk to. And, some guys have tried it in the past, maybe didn't see a return on it. And it all comes down to yield, right? Yield is what ultimately is going to move the pencil. And so we wanted to follow this trial all the way through harvest. And so what we did from there is we came back at R1. We came back at R1, we pulled plants again, and we split the stalks. And we started looking at sucrose. And we started looking at what kind of R1 efficiency or what kind of fuel tank were we able to build from that large V6 plant to R1, where now it's getting ready to enter into grain fill, because I need that sucrose in order to build my kernel depth, right? And what we found was again shocking, just on that stressy acre, that low SWI acre, was that not only did we build a bigger sucrose tank or a bigger internode, but it was completely chock full of sucrose yet to be used for grain fill. As we looked at the 12-gallon and the 7-gallon strip, we could actually see that the internodes were smaller, and even the plant was already having to tap into that sucrose reserve in order to use its sucrose for maintenance respiration, right? And you could also see that on the ears collected of those same plants that we split, that we had some tip back in those areas where we simply were running out of nitrogen, or we had a much smaller plant at V6 and it just didn't have what it needed to catch up before it got to R1 as we entered into grain fill. So it was a really fun trial that we were able to follow, and we're going to be doing a lot more trials this upcoming year, hopefully being able to repeat the exact same thing we saw in 2023.
As we look ahead to the 2024 season, how can growers plan to address those acres that tend to dry out first?
I think it starts with looking at historical yield data. Find those acres and look at the tendencies of those acres. The yield data sticks out like a sore thumb when you're crossing over those transitional slopes and those high knobs where we have lighter soils, and ultimately they burned up like we talked about before. And then I would say, consider ways that you can potentially bolster those areas with upfront nitrogen, whether that is in a pass with a planter, or it's some other type or standard of urea or ESN, something that's going to help you bolster that plant and get the biggest V6 plant mass as possible. And then just look at your overall nitrogen program as a whole and ask yourself, what can I reallocate to that planter pass? What can I reallocate to a urea pass? What can I figure out as far as organic nitrogen contribution that I'm inevitably going to get in those lower lying areas, and how can I shift that up onto the knobs and really help that area that I know is going to be stressed at some point during the growing season. And the other thing is, don't set those acres up for failure. And that's a really hard it's a kind of a hard battle that we have as farmers. Once it's fit, we got to go and we got to plant, we got to get acres covered, but take your time and make sure that things are right. Make sure we're not slicing furrows in, make sure we have really good seed to soil contact, and do everything right with the planter, so that way the starter package can assist you once that plant gets out of the ground. Because we can put all kinds of gallons, in a band right next to that seed, but if those roots get held up on a concrete wall, it's going to take a lot of rain to overcome that.
Before we go, is there anything else that growers should be thinking about from your perspective?
Yeah, 2024 is for sure going to show us its own unique challenges, right? And we're going to have to navigate those with commodity prices and other inputs that are increased right now. And the way that I look at it is, what a great opportunity we have to showcase the efficiency that we have on the farm. And if efficiency is one of those things that you personally think that your farm is lacking, or that there could be areas that could be assisted from some capacity, we'd love to have that conversation with you. That's one of the things that I think our growers down here in this area are excited about, is the fact that we are doing everything in our power to make sure that the farm is efficient as possible, to make sure that the dollars we spend are accurately going to come back as a positive ROI this year. So it will have its own unique challenges, but I would say don't be hesitant to look for other ways to become more efficient on your farm going into this year.
Really appreciate the insights today. How can growers get in contact with you and the team at Advanced Agrilytics?
Yeah, absolutely. Feel free to, look up our website, advancedagrilytics.com, or, follow us on our social media pages on Facebook or Twitter.
Again, that's Precision Agronomist Colton Zeck. And I'm Brent Barnet with Unlocking Potential on Brownfield, a content partnership with Advanced Agrilytics.